Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Muhammad Kamal Arifin. I'm from DTP5B from course DQP50152 Composite, Repair and Assembly.
Composite laminates widely used in aerospace, automotive, marine and construction industries are valued for their high strength to weight ratio, corrosion resistance and design flexibility. However, like any material, they are susceptible to defects that can compromise their structural integrity and performance. Understanding this defect is crucial for quality control, maintenance and repair of composite structures. Firstly is delamination. What is delamination? Delamination refers to the separation of layers in a composite laminate which can significantly compromise the structural integrity of the material. How it occurs? Firstly is the manufacturing error. Improper process such as uneven heating or insufficient pressure can cause pure bonding between layers, contamination between layers, impact damage, external impact such as drop tools or bird strike can cause layers to separate. Fatigue loading. Repeated cyclic loading can cause the bond between layers degrade over time. Thermal cycling. Repeated exposure to varying temperature can cause differential expansion and contraction between layers, leading to delamination. How to inspect them? So by using the ultrasonic testing, by use high frequency sound waves to detect internal defects. Delamination reflects sound waves, creating detectable echoes. Using the thermography involves heating the surface of the laminate and observing the heat flow using infrared cameras. And we can use X-ray computed tomography to provide detailed 3D images of the internal structure. And we use step testing, a simple manual method where the surface is tapped with a small hammer or coin. The relevance is the impact on performance. Delamination reduces the load bearing capacity and stiffness of the composite, can lead to premature failure under operation road, posing safety risks. Mitigation strategies improve manufacturing techniques such as automated layout and controlled cooling process. Use a toughened resin and interleaves to enhance interlaminar fracture toughness. Secondly is the void and porosity. What is void and porosity? Voids and porosity refer to the presence of air pockets or empty spaces within the composite laminate. This defect can range from microscopic bubbles to larger voids that are visible to naked eye. How it occurs? Improper resin flow. During the manufacturing process, insufficient resin flow can trap air pockets within the laminate layers. Secondly, incomplete wetting. Inadequate wetting of the reinforcing fiber with resin can leave spaces unfilled. Thirdly is contamination. Presence of dust, moisture or other contaminants can prevent proper adhesion of layer and create voids. Lastly is the volatile emission. Is the release of volatiles during the cooling process can form bubbles within the laminate. Relevance is the impact on performance. Is the reducing the strength. Void act as stress concentrators, reducing the overall strength to the laminate. Lowering stiffness, increased porosity can lead to reduced stiffness and elastic modulus. How to inspect them? Various non-destructive methods are employed to detect and quantify voids and porosity in composite laminates. So firstly is ultrasonic testing. High frequency sound waves are used to detect internal defect. X-ray computed tomography provides a detailed 3D image of the internal structure. Thermography infrared camera detects temperature variation of the surface of the laminate. Lastly is tap testing for the voids and porosity. So the mitigation strategies is optimize resin flow, ensuring proper resin flow and distribution during the manufacturing process. Vacuum bagging. Using vacuum pressure to remove air and excess resin. ensuring better compaction and fewer voids. Lastly, we have fiber misalignment. What is fiber misalignment? Fiber misalignment is in composite laminate occurs when the reinforcing fiber are not oriented in the intended direction. Misalignment can lead to a significant reduction in these properties, compromising the performance of the composite. How it occurs? Manufacturing error. Misalignment often results from error during the layout process. This can happen if the fiber are not carefully when placed in the mold. Handling issues. Improper handling of pre-impregnated fibrous material can cause fiber to shift or wrinkle. Resin flow. During the cooling process, resin flow can cause fibers to move if not adequately controlled, leading to misalignment. Tooling and fixture. Inadequate or poorly designed tooling can fail to maintain the correct fiber orientation during the manufacturing process. Inspection method. Visual inspection. Simple visual checks can sometimes detect gross misalignment or wrinkle in the fiber layer. Ultrasonic testing. Ultrasonic testing is non-destructive method use high frequency sound waves to detect internal defect, including fiber misalignment. Difference in wave propagation can indicate area where fibers are not correctly aligned. X-ray computed tomography (CT). This method provides detailed cross-sectional images of the laminate, allowing for precise identification of fiber orientation and misalignment. Chirography, an optical technique that measures the surface deformation under stress to detect subsurface defect, including fiber misalignment. What is the relevance and mitigation? So the relevance of the fiber misalignment is critical for maintaining the structural integrity of the composite laminates. Implementing stringent quality control measures during manufacturing can help detect and correct misalignment early in the process. So design consideration. Designing composite structures is considered for potential fiber misalignment, and using conservative design factors can help mitigate the impact of any misalignment that occurs. Lastly is the training. Proper training for personnel involved in the manufacturing is essential to minimize errors that can lead to fiber misalignment. So this is the defect, delamination, fiber misalignment, voids and porosity. In summary, defect such as delamination, voids and porosity, and fiber misalignment severely impact the performance and reliability of composite laminate. Delamination can severely reduce the load bearing capacity and lead to premature failure. Voids and porosity induce weak points and stress concentration that compromise the material strength and durability. Fiber misalignment disrupt the intended mechanical properties, leading to reduced stiffness and strength. Effective detection and mitigation of this defect are crucial. Utilizing advanced manufacturing techniques, rigorous quality control, and non-destructive testing method can help ensure the integrity and longevity of the composite structure. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.